Hey everyone, Professor Hank here. So today we're going to be talking about recursion in Java. We'll talk about what it is. We'll see an example or two of recursion in action, and we'll talk about some of the advantages and disadvantages of recursion. So let's go ahead and get started. So what is recursion? It's probably the hardest, simplest thing in computer science. And at its most basic, recursion is when you have a function that calls itself. And that function call can be either direct or indirect. So direct recursion is when a function literally calls itself, and indirect recursion would be if you have a function A that calls function B, which in turn calls function A again. Now, when you write a recursive function, you have basically two main components. You have what's known as a base case, and you have what's known as the recursive call. So the base case is what stops the recursion from happening. And the recursive call is the call in which the function is calling itself. And it's important that you have some kind of mechanism that causes your recursion to get one step closer to that base case. Otherwise, you end up with infinite recursion and your program will crash. So it's similar to infinite loop. You have to have something that eventually causes that loop to terminate. And indeed, you can think of recursion as another form of repetition or iteration. So let's look at some examples. Let us say that I wanted to be able to print hello on the screen a certain number of times. I'm going to need some form of repetition. And for this example, we're going to use recursion. We're going to use a recursive function to do it. So I'll create a function called hello, and I'm going to pass as an argument the number of times that I want to see hello on the screen. So I'll have a parameter named times. And remember, we talked about how we have to have a base case, and this terminates the recursion or repetitions, and we have to have a recursive call. And this is going to be what keeps the recursion going, repetitions going, and it has to get us one step closer to the base case. So what's our base case going to be? Well, as soon as times is equal to 0, there's nothing left. We've already printed out all the hellos that we want to do. So we will just return. We'll just terminate the function. Otherwise, and this is where the recursive call is going to come in. Otherwise, we're going to print hello, and we're going to call ourselves again. We're going to have us start another repetition. So we'll do system.out.println hello, and then we're going to have our recursive call. Here it comes. So it's just hello. We're calling ourselves, and we're going to move ourselves one step closer to hitting our base case. So we're going to pass as an argument one less, times minus 1. So the recursive function hello will pass it, say 3. So hello 3. So when we do that, let's trace through the code. 3 is going to be passed to times. Is 3 equal to 0? No. So we haven't reached our base case. So we skip over the return and we kick down to the recursive call. So we'll print out hello, and then we'll call ourselves again. And so what are we going to pass? 3 minus 1, which is 2. So then we're going to go again. So we go back up to the top here. And in our second instance of the function, is times equal to 0? No, because 2 was copied to times. So we skip over the return, go down to the else, we print out hello, and then we call ourselves again, passing times minus 1. So what's times minus 1 for that instance? 2 minus 1 is 1. So we go back up to the top. This is a third instance of the function being called now. Is times equal to 0? No, because we passed 1 as an argument. So the return gets skipped. And then we get down to the recursive call. We print out hello. And then we call ourselves, passing times minus 1. 1 minus 1 is 0. So we've passed 0. And so this instance of the function has been passed 0 into times. And so in this case, we are triggering our base case. The repetition terminates because since times is equal to 0, we return. Now, take a look at this line here, and you'll notice that we've got actually 4 calls to function hello. So the first time we called function hello, we passed 3 as an argument, and then it printed out hello down here, and then it called the other function. So it's waiting in memory until the other instance of itself that it created, till the next hello function call returns. And then it's similar for all the rest of them too. So this first instance of hello has to wait for the second instance, which in turn has to wait for this instance, which in turn has to wait for this instance. Now, as soon as this function terminates, as soon as it hits that return, then what happens? Then it returns back from whence it came to the previous instance of hello, which would have been this part right here. And then there's nothing else to do in the function, so it terminates. And we return to to the function that called it, and then that terminates, and we return to the function that called it, and that terminates, and then we return back to the function that called the original instance. So in our example, it's going to be, main. So I can go into main here, and I'll call the function hello 3 times. And then we're going to see in the output, we're going to see hello 3 times. Okay, so hello, hello, hello. And so we can prove to ourselves that it was actually called that many times because we can create a variable here, call it t for times. We'll initialize it to 0. And then in the function call, we'll just increment it every single time. We'll do t++. And then once that's done, we'll print out that t variable. Okay, so this is just going to count how many times hello gets called in total. And so we're going to see that it gets called 4 times. Okay, so there it is. So recursion is just another form of repetition. So let's take a look at a iterative version of our little hello function there. So we could, instead of using a recursive function, we could have said something like times is equal to 3. And then while times is greater than 0, then what we'll do is we will print out our hello, system.out.println hello, and we need a data type up here. And then we move ourselves closer to our base case. So we do times equals times minus 1. So as soon as times is equal to 0, this test expression will be false, and then the repetition stops. As soon as times is equal to 0, we've reached our base case, and the repetition stops. But so long as times is greater than 0, then we're going to have another repetition, and we're going to get closer to breaking out of the loop by subtracting 1 from times each time, and we're going to get closer to our base case by subtracting 1 from each time. Now you look at that and you're like, well, what do you mean you're subtracting 1 from each time? Remember that when you pass an argument to a function, it's like an assignment statement. So when I pass times minus 1 as an argument to the function called hello, I'm taking the result of times minus 1 and assigning it to times. So that's just like times equals times minus 1. Now let's look at another example, and in this example, we'll see how we can return values back up through the chain of recursion through return statements. So consider for a second what happens if we are working with powers, right? So if we want to do 2 cubed, right? Or if we want to do 3 squared. Okay, think about what this is. So if you do 2 to the 5th power, that's really 2 times 2 times 2 times 2 times 2. And if we limit ourselves to non-negative integers as exponents, then this becomes very interesting because 2 to the 5th is 2 times 2 times 2 times 2, but 2 to the 4th is 2 times 2 times 2 times 2, and then 2 to the 1st power is equal to just 2, and then 2 to the 0th, anything to the 0th, is defined as 1. So you can see that as we're moving down, eventually we hit 0. So this will serve as our base case in our function. Now, if we take a closer look, 2 to the 4 is defined as 2 times 2 times 2 times 2. But if you look at 2 cubed is 2 times 2 times 2. So we can define 2 to the 4th in terms of 2 times 2 cubed. Similarly, we can look at 2 to the 5th as 2 times 2 to the 4th. 2 cubed, we can look at as 2 times 2 squared. 2 squared, we can look at as 2 times 2 to the 1. And we can look at 2 to the 1 as 2 times 2 to the 0. So this right here is going to serve as our recursive call. So when you want to find 2 to the 5th, what you're doing is you're returning 2 times 2 to the 4th. When you want to find 2 to the 4th, what you're doing is you're returning 2 times 2 cubed, right, which is equal to 16. 2 times 2 to the 4th is equal to 32. 2 times 2 squared, you're returning 8. 2 times 2 to the 1, you're returning 4. And then 2 times 2 to the 1, you're returning 2. So let's go ahead and write our function then. So we'll have static int pow. We'll have a parameter for our base, and then we'll have a parameter for our exponent. So what's our base case? Our base case is when the exponent is equal to 0. And when the exponent is equal to 0, what that means is we're raising the base to the 0th power. And remember that anything to the 0th power is 1. So we return 1. So 2 to the 0 is 1. So let's look at our recursive call. And our recursive call is going to be to return our base times our base raised to the exponent minus 1. So now times the base and the exponent minus 1. Okay, so let's trace through that and see if it makes sense, just like we did with hello. So if I call pow and I pass to it a base of 2 and an exponent of 4, then what's going to happen? 2 gets copied into base, 4 gets copied into exp here. Now is 4 equal to 0? No, so we kick down to, so what does it do? It returns the base times the base raised to the exponent minus 1. And so this first instance of the function call is going to be waiting right here for the call to itself to return. So that second call is then going to start executing this code. Now is that 3 equal to 0? No. So then we go down to our recursive call. And so what is it going to return? It's going to return 2 times 2 raised to the exponent minus 1. So 2. So then we have 3 instances of the function. Now this instance here is going to pass 2 to base, 2 to exponent. Now is exponent equals 0? Is 2 equals 0? No. So we go down and we do yet another recursive call. And this is going to keep right on going. So we're going to return the base times the base raised to the exponent, previous instance's exponent, minus 1. And so then that guy is going to have 2 copied into its base variable, and then 1 copied into its exponent variable. And is 1 equal to 0? No. So we can skip that and then have one more call, and that's going to be to a function that's going to return 2 times its base raised to the exponent minus 1, which is 0. Now for this last instance of the function, 0 is an exp, so is 0 equal to 0? Yes, so this is going to return 1. So that evaluates to 1, and so since that's what's returned, then this becomes 1, and then 2 times 1 is 2, and so then that gets returned to this instance at 2, and so then 2 times 2 is 4, and then that gets returned to this instance. And since 2 times 4 is 8, that gets returned to this instance. Since 2 times 8 is 16, that gets returned to this instance, and we're done. So that's how that works. Now let's test it. So system.out.println pow2 4. We'll see what we get. It should be 16. And there it is. Now notice we can make this slightly more efficient, right? We don't have to go down and have that last instance of the function. We could check to see if the exponent is equal, and then just return the base. And then just return the base. And then we'll see that we have one fewer function call, because as soon as the exponent is 1, then the recursion terminates, right? So we get the exact same value. Okay, so let's take a look at another example, and let's consider this time factorials. Remember what a factorial is? Factorial is something like this. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 4 factorial is equal to 4 times 3 times 2 times 1. 3 factorial is equal to 3 times 2 times 1. 2 factorial is equal to 2 times 1. 1 factorial is equal to 1 times 1. And 0 factorial is equal to 1. So we can see, similarly to how powers were defined in terms of themselves, we can see that a factorial is defined in terms of itself as well, because we can see that 4 times 3 times 2 times 1 is equal to 4 factorial. 2 factorial is equal to 2 times 1 factorial, and 1 factorial is equal to 1 times 0 factorial. So we can write a recursive function for this. So another way of looking at it would be factorial of 5 is equal to 5 times factorial of 4. Factorial of 4 is equal to 4 times factorial of 3. So when we try to find 5 factorial, what it's doing is it's returning 5 times factorial of 4. So it's evaluating to 5 times factorial of 4. So this is a recursive definition. So let's write a recursive function that will figure out factorials for us. So we'll do static int fact, and then we're going to pass to it some number. Now, what is going to be our base case? We saw that 0 factorial is just 1, so we'll make that our base case. So if the number is equal to 0, then we'll just return 1, because 0 factorial is 1. So this is our base case, and then we'll have our recursive call. Else, remember we returned the number times the factorial of the number minus 1. So this is going to be return num times the factorial of the number minus 1. Now that's hard to see. We can generalize this up here, right? We can say that n factorial is equal to n times n minus 1 factorial, and 0 factorial is equal to 1. So these are our two pieces. This is our base case, and this is where our recursive call comes in. Okay, so let's go ahead and give it a test. So we'll do fact of 5. Okay, so what should fact of 5 be? Well, 1 factorial is equal to 1, 2 factorial is equal to 2, and then 5 factorial is equal to 120. So let's try it. Okay, so you can see there's the 120. Okay, so let's finish up by comparing and contrasting recursion versus iteration. So recursion, that's what we just saw, function that calls itself. Iteration, that's using loops. So advantages of recursion, very, very short, concise, clean code, very elegant. You can express a solution to a very complicated problem in a simple if-else statement. Very readable, and it's very well suited whenever you have problems that can be broken up into smaller, easier subproblems. Divide and conquer. What about advantages of iteration? Well, they're more efficient because you don't have to create additional instances of functions, because when you have a function that calls itself, every time it calls itself, that's all of that overhead for creating the function, copying arguments into parameters and so forth takes time. With loops, you don't have that. And sometimes it's just easier to think in terms of iteration, in which case it's a lot more predictable when you're looking at the code as to what it's going to do. Recursion is a very abstract concept and forces you to think in a different way to shift your paradigm. And that can be difficult. And that's why I said at the very beginning that it's the hardest, simplest part of computer science, because when you understand recursion, it's a very simple thing. But until you can make that shift in your thinking, it's difficult. So now you know the fundamentals of recursion in Java. As usual, if you're a student of mine and you have any questions about any of the content in this video or any of the videos in our courses, feel free to drop me an email via Canvas or stop by my online Zoom office hours. Thanks for watching, and we'll see you next time.